Hello, everyone. This is one of a series of short interviews that I've been conducting at the Bay Area Alignment Workshop, which is run by FAR.AI. Links to what we're discussing, as usual, are in the description. A transcript is, as usual, available at axrp.net. And as usual, if you want to support the podcast, you can do so at patreon.com/axrpodcast. Well, let's continue to the interview. Yeah, so Zhijing, thanks for coming on the podcast.
Yeah, thanks for inviting me.
Yeah, so I guess first of all, we're here at this alignment workshop thing. How are you finding it?
Very excited. I just finished a session about AI governance and a bunch of one-on-ones, which is super interesting.
Cool. Yeah, so as I understand it, your work, at least predominantly, is in natural language processing and causal inference. Does that seem right?
Yeah. That's a topic from my PhD, and I'll bring it in my new assistant professor role as well.
Right. Oh, yeah. I guess I forgot to say, yeah. So you did could you tell us where you did your PhD and where you're about to be?
Sure. So my PhD started in Europe, so Max Planck Institute in Germany and ETH in Switzerland. So it's a joint PhD program. And I'm graduating and taking the assistant professor role at the University of Toronto, CS department.
Yeah.
Next year.
Very exciting. Cool. So I guess so I'm aware that there's like a subset of people in AI who are interested in causal inference, and there's a subset of people in AI who are interested in natural language processing. And especially if I understand correctly, when you started your PhD, it was a bit more niche. It's not like, everyone's into language models now, but so I'm wondering how did you come to be interested in the intersection of these two things, which it seems like when you were interested, neither of them were the main thing. So getting into both of them is kind of unusual.
Totally. Oh, that's such a great question. I started in my undergrad having a strong interest in natural language processing, and slightly different from, at that time, a bigger branch like linguistics and understanding like different devices people use in language. I'm always more interested in the semantics, like what meaning do they convey? What are they able to do, and so on. And then that actually naturally connects. At first, people were thinking about how can we make these models more capable of what people expect them to do. And then once they show tendency to exceed certain behavior, then we start to worry about what might go wrong and how to really align with what human society asks for. So actually naturally develop into this. And I also thank a lot to my undergraduate friend, Cynthia Chen, and she introduces me to all these goals of alignment and Chai lab that's set up at Berkeley and so on.
Gotcha. So I think a lot of people are interested in alignment, making sure that models, don't go haywire. But I think a lot of people and a lot of our listeners don't necessarily see that as being super connected to causal inference, or don't focus on that aspect. So what do you see as the connection between alignment in general and kind of causal stuff in particular?
Yeah, so basically causal inference originated as an important device for us to know more about two things at first, like how nature works, and then also how humans work. For example, in the last century, a famous causal inference problem is, does smoking really cause cancer? And then the interesting statistical advancement people made is that, can we get a causal conclusion without forcing people to smoke?
Right.
And then now we can totally shift all these tools to LLMs, in that, can we understand what contributes to LLM's behavior like this? And then, so there are several ways causality can contribute here. The first question that I just mentioned is an interpretability problem. We see demonstrating different types of behaviors, capabilities. Can we interpret what circuit, what neurons lead to that?
Yep.
There are also people exploring what type of training procedures lead to them. And then another side is do LLMs really know the consequence of their actions? And I do believe that a lot of the safety work, especially with my recent interest in multi-agent LLMs, it composed of a two-step process. First, knowing the consequences of your actions. If I do A, what will happen? If I do B, what will happen? a very thorough causal inference understanding, and then later on a moral module add on top of it, or a reward model, in that what will A mean for other people, for the society, what will B mean, and then which consequence is more preferred. So it's like, yeah, first knowing and then deciding.
So one application of causal inference to language models is, kind of understanding what is causing language model behavior. Another is like, do language models understand causality? Did you say that there would be a third thing, or did I just misremember that?
That's mostly the two big threats.
Gotcha.
I'm also slightly interested in narrow AI. So basically, in the past, human scientists apply causal inference to understand, let's say, what's the effect of increasing minimum wage.
Yep.
Does it reduce employment rate or does it not? That's 2021 Nobel Prize in economics. And then I'm actually also, so at Toronto, we have this organization called SRI. And that also focuses on how AI can be deployed to help a lot of social problems. That's one of my interests as well.
Gotcha. So one thing that strikes me about the first thing you mentioned, using causal inference to understand, what things in AI cause various AI's behavior. Like, it sounded like you were applying that stuff in the model, right? Like, oh, if this neuron fires, that causes this thing to happen. So I've studied a little bit of causal inference, and from what I remember, it seems like it's very dependent on like there being some randomness, right? Like, you have this like probabilistic network, and like you check if things are correlated or not correlated, and like that lets you draw these like Bayesian DAGs, and there's your causality. So this is like my half-baked memories of it, right? But a lot of this breaks down if like everything's deterministic, right? Like if everything's deterministic, then everything is sort of perfectly correlated in some sense. It's like kind of hard to get stuff that you might want. So how can you apply causal techniques when you have this deterministic system?
Yeah, so that's a great question. And also, I guess the direct analogy was that in neuroscience, people like where the subject is people, whereas when we move to models where the subject, like we can intervene it in any sense. So for neuroscience, the difference of correlation and causation is pretty clear in that correlation means that you ask the subject to do a certain task and observe what part of the neurons are activated.
Yep.
And that's correlated. Whereas the causal sense of it is usually got from patients who had brain damage and so on. So actually ablating that part of the brain region will happen in their task completion.
Yep.
Moving this to LLMs, we also had a previous early stage of interpretability where people look at the activation state and the model prediction, or trying to interpret how this model understands the nature of the word here, the meaning, like the syntax tree and so on. Whereas here, like in the, I guess it's also popularly known as the mechanistic interpretability research,
Yep.
the causal notion is that we really intervene on the neurons and see what's happening. That's the first level in terms of, I guess there are maybe 3 different levels, different types of causal inference that's applied on interpretability. The first one is like directly ablating a certain neuron, set it to a certain value, and then see what will happen, or entries in the attention matrix. The second type is basically the so-called mediation analysis, where you basically control the neurons to be of 2 states. One is like maybe an intervene state, some control state to single out which part really does the job. And then the third branch is, so all of the previous 2 are still neuron level interpretation, like, whereas the third branch is this causal abstraction where you try to match a bunch of neurons to a certain function and then understand in a macroscopic level.
Yeah, if people are just not very familiar with this literature, like where's it at? How good a causal understanding can we have of networks?
Yeah, so I think it's becoming more and more a drive of interpretability. And we will have a NeurIPS 2024 tutorial on causal LLMs as well, where a big part will introduce this.
Sure. So one thing that kind of caught my ear was the causal abstraction stuff, right? Like kind of abstracting beyond the neural network, beyond the neural level using causal techniques. Can you say a little bit more about the state of the art in that work, like what we've learned?
Yeah, so I guess like some earlier work usually hypothesize that, okay, there's a computation graph that we believe is like solve the problem, and then try to map different neurons function to the corresponding unit in that like more abstracted computational graph.
Right.
Yeah, and then I guess the recent SAE, sparse autoencoder, also has similar notion in that it's trying to map this like neuron space, which is much higher dimensional, to a relatively lower dimensional space. And this is relatively, so as mentioned, like the previous, the earlier work is more on a top-down approach where we hypothesize the computational model, and then like the SAE is a little bit more in the bottom-up. And I hope in the future there will be more work emerging from that. And also in our causal inference lab, we always draw analogy to how the history of science advances. For example, by observing what's happening around us, we distill Newton's law. And that's like also from all the pixels that we see to what is mass, what is acceleration, what is force, and so on.
So the next thing I wanted to ask is, so the main other type of causal inference work you mentioned is having neural networks understand kind of the causal impacts of their actions. I think in a lot of the field of AI, this isn't thought of in causal terms. People think like, okay, like we'll just have some probabilistic model of what's the probabilities of like, various stuff happening conditioned on actions. What do we buy by thinking about it in a causal frame?
Right. So I guess it's a lot about what is abundant, which is observational data, and what's relevant for decision making, which is like essentially interventional. We need to do an action, see the real world effect. And I guess also it's not only the LLM agent knowing about its own consequence, but also knowing more about the world. Let's say that for us human agents, pending pressing question is, for example, who to elect as the president. And then that's also a lot of causal contribution for us. Like we haven't seen a world where Harris is the president and how that will be, or haven't seen how, given the current international situation or domestic situation, how Trump will act. But we are trying to attribute like, okay, we want to achieve a certain goal. Everybody cares about certain things. Is Harris more of the cause or Trump more of the cause to that? So any decision that people make is fundamentally causal here.
Okay. And can you give us a flavor of just like what work is being done to understand kind of LLM causal reasoning, and just to give us more of a flavor of it?
Yeah, so we have done a couple of studies on that, and there are also awesome researchers in the field of NLP, machine learning, building more causal agents. And for us, like we had a previous work at iClear 2024 this year we present to them a bunch of correlations. And let it try to make sense, and which one should be understood as a causation, which one stays as correlation. You wouldn't expect anything from intervention later. And this whole problem setup was inspired from if we have humans, like because we lack the real counterfactual world, we lack access to that. We basically keep reading news articles, we keep hearing about anecdotes, and we need to figure out like what really makes sense.
Okay. So you're presenting these like correlations to neural networks, asking them to figure out like which ones are causal. Yeah. How are you presenting those correlations? Like what are you actually training a model on?
For that one, it's basically like we draw the study, like it's a field called causal discovery.
Yeah.
And then we tell it a lot of cases, okay, A correlates with B, B correlates with C.
Okay. So you sort of tell it in sentences because
yeah.
You could just do that. Okay. So yeah, how do language models perform on this task?
Actually, it was pretty badly. Like a lot of like off-the-shelf LLMs directly evaluated on that were maybe only marginally above random, including also GPT, some latest GPT models.
Okay.
And we also would perceive like this is sort of a slightly different question as if you directly ask does smoking cause cancer?
Yeah.
Because here you require the reasoning process and like you need to like build from scratch. Here the correlations make sense of it instead of remembering some literature, remembering the all the previous documents and so on.
Yeah. So if the latest, if the new hot models just aren't very good at this task, like, does that let you make some prediction about like various things that they are going to be bad at that that we could then check out?
Yeah. So I guess like there are different usage scenarios of these LLMs. Something that I keep being unsatisfied about is when we chat with that and ask about a pretty essential problem, and its current solution is here are the 5 factors that matters,
Right.
and then stuff, but didn't tell very exactly like what might be the problem and so on.
Right. So sort of just diagnosing and fixing like, things in like the messy real world where you can't just like remember a list. Maybe that's going to be a thing that models are going to struggle with.
Right.
So I also want to talk about some other work you've done. So I understand that as well as natural language processing and causality, you also have some work on, or thinking about multi-agent systems. Can you say a little bit about what your interest is in there and what you're doing?
Sure. I was pretty impressed by the rising trend where people, I guess it started from the generative agents work, where there's this idea of we can build a digital village where each LM play a certain character and see what will happen among them. And I see a lot of like possibilities from that. First of all, like we like a lot of times before we were thinking about benchmarking LMs, understanding them, but implicitly as it assumes single agent evaluation. And then
Right.
that's a scheme to move towards multi-agent systems. And it could be about how they collaborate, or it could be about how they cheat against each other, and so on. Moreover, that's the pure, let's say, LM AI safety. Like we build this LM society and only care about that. There's also some analogy that we can draw for human society, on the other hand. Like we can simulate characters that are close to maybe some international players that we are seeing these days and see if you do this, what will happen, and so on. So I have a long-lasting passion in policies and so on. So it will also help being a testbed for testing policies.
Gotcha. Yeah. So if I think about work that's been done, so I can't think of a ton of work that's been done in this domain, even though it seems interesting. Like there's a lot of multi-agent work sort of in a reinforcement learning setting. In this setting, I guess I have some familiarity with like some work getting like language models to make contracts with each other in Minecraft to cooperate, but it seems like maybe an underdeveloped field. Yeah. So I'm wondering like specifically, are there any experiments that you'd be like really excited to run, or I don't know, maybe you don't want to scoop yourself, but yeah, can you tell us a little bit what this might look like concretely?
Yeah, it's a very nascent field. We have recently finished. I always draw inspiration from interdisciplinary things, and recently we have a NeurIPS 2024 paper on whether LLM agents will demonstrate the tragedy of the commons. So we basically put a bunch. Also specifically, we focus on things that only demonstrate in a multi-agent situation. In that one, we put a bunch of agents together in a simulated village and see whether. So in human society, the tragedy of the commons is usually set up as, for example, we have only one environment, but maybe if all of us want to consume from it, then in the end, like there is this climate change, there is this like pollution problem. Similarly for LMs, we define like how it can harvest and what are the constraints of this shared pool of resources. And we simulate a whole calendar year where LMs go through many iterations of now it's the point where you decide how much you want to harvest. You know that the limit of the resource is this, its replenishing rate is like that. And you know that there will be also other LLMs. So at every iteration, we make 3 different stages. The first one is the action stage, where you decide how much to harvest. Then it's a discussion stage. It's a little bit like a town hall meeting where all the agents talk to each other, and they can point fingers at some more greedy agents, or they can set up rules and so on. And then in the last stage, it's a reflection, like they try to compile information from this whole iteration and the history, and think about making plans for the next round and so on. And amazingly, also like a little bit pessimistically, we observe that many of the agents have 0% survival rate, means that they drain the common resource in the middle, and actually also in a very early stage. That also actually include a lot of models that's claimed to be safety tuned, such as a lot of Anthropic's model as well. And most of the open source models that we've tested, including Llama and so on, also collapse very early and have a survival rate of 0.
Yeah. Wow. This seems bad. So we're about at the end of the window I booked, and I don't want to use up more of your time. But thank you very much for chatting with me.
Yeah, thank you so much for the interview.
This episode was edited by Kate Brunotz, and Amber Dornace helped with transcription. The opening and closing themes are by Jack Garrett. Financial support for this episode was provided by the Long-Term Future Fund, along with patrons such as Alexei Malafeyev. To read a transcript of the episode, or to learn how to support the podcast yourself, you can visit axrp.net. Finally, if you have any feedback about this podcast, you can email me at feedback@axrp.net.